Welcome to Easy Elim, Learning Simplified. My name is Ruth, and today we are going to be learning on the topic on air and combustion, and specifically we are going to be looking at rusting. Initially we talked about how rusting occurs, and also we looked at the conditions necessary for rusting and also what accelerates rusting. So today we are going to be looking at how can we prevent rusting from occurring and what are some of the disadvantages of rusting. So one of the methods of rusting is galvanization. Galvanization is the coating of iron with a small layer of zinc, and it can be done either by dipping the iron in the molten zinc or spraying it with molten zinc. So in simple terms, zinc is the one that is covering or coating iron. And if you look at where zinc is in the reactivity series, you realize that zinc is more reactive than iron. And that's the reason why what happens if zinc is exposed to the air and water in the atmosphere, it reacts at the expense of iron. So it reacts on behalf of the iron. So the iron do not get that chance to rust. So an example is the wire mesh we are seeing at the picture below. You can see the wire mesh has been coated with zinc, and you can see it is not rusting because the zinc is the one that is preventing it from rusting. The second method is electroplating. Electroplating is coating iron with other metals using electricity. So it usually occurs in a process we refer to as electrolysis. You are going to learn this more later on when you get to Form 4. And then we're also going to look at an example later on. But one of the common examples is tin coating. Coating iron with it can be any less reactive metal like tin. For example, you can see these tin cans here. It's very common with packaging tins. They cover it with tin because tin does not react. So you can see the difference between galvanization and electroplating is that galvanization, you're coating with zinc specifically, but it is more reactive than iron. Electroplating, you're coating with metals, but metals that are less reactive than iron. Next, we are going to look at sacrificial protection. For sacrificial protection, more reactive metal is attached to the iron structure. So the more reactive metal will corrode instead of the iron, and then the iron structure will be kept from rusting. And you notice that these more reactive metals must keep on being replaced regularly. A common example is the hull in the ships. They're usually attached to a more reactive metal down below here. And zinc is more reactive than iron. So what happens when rusting occurs? Zinc will react on behalf of the iron. So it's the one that is going to react with air and moisture. So zinc needs to keep on being replaced now and then. And next, we are going to look at painting. Is another also method of preventing rusting. For painting, the metal surface is covered by a paint. These paints usually prevent the iron from having contact with air and water. And then if the paint is scratched, rusting will definitely occur. You have seen that in most of the iron sheets that are usually painted in iron sheets. And then you can also see some of them in gates and also in cars. We know cars are usually painted, and sometimes when that paint is scratched, it can cause the car to rust faster. Next, we are going to look at alloying. Alloying involves mixing two or more metals. These metals make the final product to be stronger, and the final product does not rust. And this is very common, especially in most of the metals that are used to make different substances. A common example is the wheels of a car. The metal that is used to make the wheels is usually made of an alloy, and this alloy is very strong. It does not rust. And then finally, there is oiling and greasing. Oiling is used for moving engines, and then grease is used for movable metal joints. You have seen this a lot, especially in places where cars and moving vehicles and also bicycles are done, most of them there is greasing that usually occurs. Grease prevents a barrier from the reaction of water and air from coming into contact with the metal surface, so it prevents it from rusting. An example is the engine oils. We know that they're usually filled with oil, and this oil helps the parts to move easily. So we're going to do one question in regards to what we have discussed and see if you have understood what we have discussed. So the diagram below represents two iron nails which with some parts wrapped tightly with zinc and copper strips respectively. So we have the iron nail. Both of these are iron nails, and they have been wrapped with zinc strip. The other one has been wrapped with copper strip. And the first question is, what observation would be made at the exposed point A and B? So we look at point A and point B. What would happen if the nails were left in the open for several months? Explain. So if you look at the strip that is covering zinc, we said zinc is more reactive than iron, so it is going to rust on behalf of the iron because it's more reactive. And then also when you look at the copper strip, we know that copper is less reactive than iron, so what will happen, iron is going to rust on behalf of the copper. So one of the observations you notice in B, there will be a brown coating, and then in A there will be no brown coating. And we have said and explained the reason why there is no coating in A is because zinc is more reactive than iron, and in B copper is less reactive than iron, so iron is going to rust on behalf of the copper. So that brings us to the end of the session. I hope you have been able to understand. Let's meet for the next session. Bye.